Hi friends, in this session we solve some numericals of trigonometrical identities. So here you see prove that the following questions using trigonometrical identities. There are 4 questions here in this question number 1. We have sub questions 4. So we have to use the trigonometrical identities. We know all the 3 identities. First I would like to explain how to solve this question. We start with question number first. Now we see the solution for this question. Solution for first. The question we have 1 minus cos square theta minus sin square theta is equal to 0 because LHS is equal to 1 minus cos square theta minus sin square theta. So what we have to do, we know that. So first what we do, 1 minus, we are taking minus outside from these two. So 1 minus cos square theta plus sin square theta is equal to 1 minus 1 finally, which is equal to 0, and this 0 is equal to RHS. So here LHS is equal to RHS. Why it is 1? Because we know the identity first identity of trigonometry, sin square theta plus cos square theta is equal to 1. So we have put instead of this cos square theta plus sin square theta is equal to 1. So 1 minus 1 is equal to 0. So now we solve question number 2. Solution 1 of 2. Here we have the second question, 1 plus cos theta over sin square theta is equal to 1 over 1 minus cos theta. We have to prove this. One plus cos theta over sin square theta is equal to 1 over 1 minus cos theta. This question we have. Now we solve this. Because LHS is equal to 1 plus cos theta over sin square theta. So 1 plus cos theta over 1 minus cos square theta. Why it is so? I explain you here. Because we know that sin square theta plus cos square theta is equal to 1. So if I transfer cos square theta to other side, so I will get 1 minus cos square theta on the right side. So it is equal to sin square theta. So instead of sin square theta, we have to putting 1 minus cos square theta. Now the next step, 1 plus cos theta over 1 plus cos theta into 1 minus cos theta. I explain you this now. Because we know that a square minus b square is equal to a plus b into a minus b. This algebraic identity we are using here in the denominator. 1 square is 1. So 1 square minus cos square theta is equal to 1 plus cos theta into 1 minus cos theta. Now look at here. Here is 1 plus cos theta in numerator and 1 plus cos theta in denominator. So they will eliminate each other. Or here we get 1 over 1 minus cos theta. And 1 over 1 minus cos theta, look at here in the question, we have to prove this. LH is equal to RHS now. So here it is equal to RHS. So LHS is equal to RHS. So in this way we have to prove this. Now we take next problem. The next problem is 1 minus cos square theta over sin square theta is equal to 1. Solution 1.3. 1 minus cos square theta over sin square theta is equal to 1. Because we know that LHS is equal to 1 minus cos square theta over sin square theta. Therefore, sin square theta over sin square theta. I explain why. Because sin square theta plus cos square theta is equal to 1. So if I transfer cos square theta to other side, so I will get 1 minus cos square theta is equal to sin square theta. So instead of this 1 minus cos square theta, I am putting sin square theta here. So we see here both will eliminate each other. So we get here 1, which is equal to RHS. So LHS is equal to RHS here. Now we see the next problem. Cos square A plus 1 upon 1 plus cot square A is equal to 1. (1.4). We have the problem. Cos square A plus 1 upon 1 plus cot square A is equal to 1. So we see the solution for this. Because LHS is equal to cos square A plus 1 over 1 plus cos square A. Therefore, we get here cos square A we put as it is, and it is cot square A. So 1 plus cot square A is equal to cosec square A. This is the identity we are using here. We know this identity. 1 plus cot square A is equal to cosec square. This is the basic identity we are using here. 1 plus cot square A, instead of this we are putting cosec square A. In the next step, cos square A plus sin square A. So I write down this identity here, because sin A is equal to 1 upon cosec A. This is the reciprocal formula for this. And the next step, because we know that the sin square A plus cos square A is equal to 1, so it is equal to RHS now. LHS is equal to RHS. Here I am putting this identity too, because sin square A plus cos square A is equal to 1. So these identities we are using here, and solving this sort of problems we could easily solve using the identities. All the three identities we have to keep in our mind, and we could easily solve out this question.